America is the world's leading agricultural powerhouse.
But each year, a silent disaster unfolds across these fields.
$350 million of apples, a colossal number. They never make it to the market.
Never appearing on anyone's dinner table.
Why does a nation with cutting-edge technology tolerate hundreds of millions of pounds of apples being discarded like waste? To find the answer, we must go back to the starting point, where 11.7 billion pounds of apples were born.
The coloration on this lot is excellent, very little bruising.
Yeah, we were careful with the pickers this season. The refrigeration is holding steady too.
The gamble begins in early spring, when the soil has just thawed.
This isn't simply gardening, it's a long-term investment.
A young apple tree needs 3 to 5 years to produce its first crop.
And sometimes it can take up to a decade for it to reach peak yield. To operate this biological factory, the first requirement is energy.
At least 6 hours of direct sunlight each day.
The soil must also be precisely calibrated. Good drainage, sufficient moisture retention, with pH maintained between 6 and 6.5.
But the real secret to American productivity lies here: grafting technology.
Modern apple orchards don't just plant trees naturally.
They assemble them. Each tree is a composite of 2 distinct parts.
The underground portion is the rootstock, the chassis that determines size and cold hardiness of the machine.
The other part is the scion, the brain that dictates the apple variety and commercial fruit quality. Thanks to this biological assembly technique, farms have pushed production limits to the extreme. Planting density reaches from 1,800 to 2,000 trees per acre, optimizing every inch of land.
But high density means structural risks.
From the moment they're planted, these apple trees need stake and trellis support systems.
They're like the steel skeleton of a building, keeping the tree upright.
And preparing to bear the enormous load of thousands of tons of fruit in the future.
The root system has taken hold in the soil. The skeleton is now built.
This biological machine begins demanding fuel to operate. Spring and summer are the most energy-intensive phases.
Each individual apple guzzles from 52 to 79 gallons of water per week.
With thousands of trees per acre, manual irrigation is impossible.
Farm owners must deploy smart drip irrigation networks, managing water precisely to the drop. Alongside fueling is the structural calibration process, pruning. Growers must ruthlessly remove weak branches.
Their goal is to create an open canopy framework, allowing sunlight to strike each apple directly.
Only full light produces the color and sweetness needed for commercial standards. But nature never compromises easily. The biggest enemy still lurks: temperature.
The safe temperature for pruning is above 20 degrees Fahrenheit.
If temperatures drop below the 16 to 20 degree Fahrenheit threshold, disaster strikes.
The cuts become death portals.
And even if they survive the cold, this factory can't operate without its most critical step: pollination.
Most commercial apple varieties can't self-pollinate. Machinery is useless here.
To solve this, farmers must hire a biological mercenary army.
Millions of bees.
The cost to maintain this force isn't cheap, ranging from around $65 to $120 per hive.
Their mission is to ensure maximum fruit set rates.
But ironically, too much success is also a problem. If all of the set fruit is kept, the branches will snap under their own weight.
Farmers must make a ruthless decision: thinning.
They must thin out branches, maintaining spacing of 5.9 to 7.8 inches between fruits. By eliminating the weaker ones, the tree channels all nutrients to the survivors.
Only the largest, most beautiful fruits are allowed to proceed to the next stage.
When harvest season arrives, the year's biggest operation officially begins. At industrial-scale farms, the goal is to gather massive apple volumes of 5,000 to 7,000 tons in just a few short months.
From mid-August to November,
For premium products like fresh apples, machines still can't replace the human's hand sensitivity.
This is where the core migrant labor force from Mexico, Venezuela, and Guatemala is mobilized. Market rates for these type of skilled workers aren't low, ranging from $20 to $40 per hour.
A professional worker can harvest up to 8 large bins of apples per day.
But this isn't mere manual labor. It's precise, repetitive technique.
Rule number 1, no yanking.
They must gently push with fingers or twist the fruit upward to keep the stem intact.
This ensures freshness.
For varieties with tough stems, farmers must use clippers to shorten them.
Point, preventing the stem from becoming a weapon that punches other fruits when packed into bins.
However, the biological limits of humans are a barrier to profits.
Time-consuming and costly.
To break this limit, technology intervenes. The first stepping stone is semi-automated systems.
Mechanized lift platforms combined with conveyor belts bring workers safely to high branches, boosting team productivity by 30%.
But the real power lies in the processed apple segment, where perfect appearance isn't a priority. Here, the mechanical monsters are truly unleashed.
The first type is the shaker machine.
Its hydraulic arm clamps onto the trunk like a giant vise,
generating extreme vibrations to shake all of the fruit onto the grass or catch it nets in just seconds.
The second type is the over-row harvester machine.
This massive vehicle directly swallows entire rows of trees into its maw, using rotating rollers that continuously shake it.
Its operating capacity is devastating, harvesting 8 to 10 tons of apples per hour.
Let's see how these machines work.
It doesn't stop there. The future of this industry is being shaped by robots and drones. Camera systems scan images to identify ripe targets, guiding robotic arms to pick fruit with absolute precision.
Though current investment costs are high, they affirm the inevitable trend.
full automation.
Despite support from advanced technology, the apple industry still faces a brutal market reality: oversupply. When supply exceeds demand, packing plants overload, and market prices plummet freely.
When selling prices don't cover harvest, transport, and packing costs, farmers must make a loss-cutting decision.
Let the apples rot right there in the orchard.
This is the answer to the paradox of the 350 million pounds of discarded apples we mentioned.
Others opt to report losses for insurance payouts, instead of futilely harvesting.
But for the apples that survive nature's and the market's harsh selection, their journey continues at modern processing complexes.
Here, apples are transported via water channels to minimize impact and reduce bruising. The cleaning process starts with recirculating water baths containing chlorine solutions to eliminate bacteria, followed by high-pressure spray blasts.
Next is the toughest checkpoint, the electronic judge.
Automated optimal sorting systems use high-resolution cameras combined with color and weight sensors to scan each apple.
It evaluates size, gloss, and detects the smallest defects the human eye might miss.
After passing inspection, apples are coated with a thin layer of food-grade wax to replace the lost natural bloom,
locking in moisture and maintaining a perfect appearance. Then, they're carefully packed into cartons or plastic bags, ready for transport to various markets.
The finest ones go to controlled atmosphere storage rooms, where oxygen levels are minimized.
This is artificial hibernation.
The apple's respiration slows to a halt, allowing them to retain original freshness for months.
Another portion becomes raw material for the booming cider industry, with a market size projected to exceed $600 million by 2026. This juice is fermented for 5 to 14 days, then aged in stainless steel tanks or oak barrels.
Point for up to 6 months to develop complex flavors. Finally, it's bottled in glass, sealed, labeled, and packaged for shipment.
Each step contributes to a premium wine with full, complex flavors. Each bunch not only carries the flavor of soil, sun, and rain.
All right, bring it back slow, easy. Watch that corner, hold it, stop right there.